Okay guys, so today we're going to be talking about the mole and molar mass. Okay, so that's going to be the title of the notes, the mole and molar mass. So let's start with the word mole. Mole is just the SI unit for an amount of a substance. How much do I have? Mole can be abbreviated MOL, but remember M is already taken with mass, so you have to abbreviate it MOL, or you could just spell the whole thing out with MOLE. I know it seems silly. The actual definition of a mole is that a mole is the same amount of a substance that contains as many particles as there are atoms in 12 grams of carbon-12. That's our book definition, but I wanted you to see it because it's a little bit wordy, so I want to pick it apart. What does this -12 mean right here? So this -12, remember, that just means the mass number of that isotope. And if we're counting particles, remember we're counting something that's really, really tiny. So we're going to get a large number. We're going to talk more about that in the next video. But I wanted you to just have an idea about how they're defining this word mole. It's a made-up unit so that we can deal with smaller numbers than having to deal with particles that are a much larger number. The reason we're talking about mole is because today we're going to talk about molar mass. Molar mass is simply the mass in grams of 1 mole. Molar mass is really, really simple, okay? So don't overcomplicate it. The molar mass is always equal to the average atomic mass on the periodic table. So let's do a few examples. Right? If we have an example, let's say, what's the molar mass of copper? You simply look at your periodic table, and it says 63.546. What would my units be right here? Well, it's a mass, and mass is measured in grams. So we put a G after it. Okay? But what if we had something like oxygen? Remember, oxygen is genuine, it's diatomic. When I look at my periodic table, I find that oxygen's mass is 16. We're just going to round it up. I know it says 15.9999. We're just going to round it to 16. But I see that I have 2 of them. I don't add, I'm going to multiply. So 16 times 2 gives me 32 as my molar mass of oxygen gas. And again, that's in grams. Remember to always put a unit with your numbers. All right, let's do another example. Let's say I have iron 3 oxide, right, which is Fe2O3. I have iron and I have oxygens. So I have to look at the periodic table to find the mass of iron. Iron on the periodic table, it's number 26. The mass says 55.845. And I have 2 of them. So I need to multiply times 2. I'm going to take my handy dandy calculator, right? And I'm going to type in 55.845 times 2. Gives me 111.69. Then I also have to look at my oxygens. Again, oxygen weighs 16, and I have 3 of them. And 16 times 3 gives me 48. Then I have to, when I look at both of these numbers, I add them together. And I get a total molar mass of 159.69 grams. Okay? We're going to do one last example, and this one's going to involve parentheses, so it's going to be a little more complicated. We're going to do ammonium sulfide. Ammonium is NH4, and sulfur is an S, and I cross that charge down to get that 2. This 2 matters when we do molar mass. So I've got nitrogen, hydrogen, and sulfur. Nitrogen weighs 14, hydrogens weigh 1, and sulfurs weigh 32. I got all these numbers from the mass on the periodic table. But how many nitrogens do I have? So remember, like the distributive property in math, this 2 distributes onto that nitrogen. So that's 14 times 2 gives me 28 as my mass of nitrogens. This also distributes onto the hydrogens. But I already have 4 hydrogens inside and a 2 on the outside. Again, I multiply. What's 4 times 2? 8. 1 times 8 is still 8. And there's only 1 sulfur, so it stays at 32. Once I get all my individual element masses, I add them together. 28 plus 8 plus 32 gives me 68 grams as my molar mass. Now I want you to try on your own. So get out your worksheet and try molar mass problems.